This video goes over measures of spread. And so what measures of spread indicate is how closely a set of data clusters around its mean, which is important when you are trying to interpret the results from an experiment or a survey. So the first term that we need to be familiar with is deviation, which is the difference between a particular piece of data and its mean, so the mean of the data set. And then we have the standard deviation, which is the square root of the mean of the squares of the deviations. So this is a more holistic definition, the standard deviation, whereas the deviation only refers to one particular piece of data. So the formula that we have for the standard deviation is sigma, lowercase sigma this time, is equal to the square root of the sum of the deviations and then divided by n, which is the number of pieces of data that you have. So you might ask, why do we need to square the deviations to figure out the overall standard deviation of a data set? Deviations can be positive or negative because your data points can be above or below the mean. So if we add them together, they can cancel out, which doesn't give an accurate representation. So what we do is square them, add them, and then square root them together. This is a formula I will give you on a quiz or a test or assignment. You don't need to memorize it, okay? But we'll go through a couple examples of how to calculate it. So in this first example, we have the scores in a recent golf tournament are as follows. Okay, we've got 10 scores there. And what we're going to do is calculate the standard deviation. So the first thing that we need to do is record all our data points here. It doesn't really matter if they're in order or not, because we're not trying to find the median or mode at this point. 96 and then 80. And then before we complete the second column, we need to figure out what our mean is. So this is something that you don't really need to show a lot of work for. You can just do on your calculator. So we know that x bar is going to be the sum of our data values divided by the number of our data points. And when you do this, you should get 86.1. When you're calculating the mean, you always want to calculate to one decimal place, okay? So then in our second column here, to calculate the standard deviation, we're going to take our x value, which is our data point, and subtract the mean. You can get negatives or positives here. You should check this out with your calculator and make sure that you are getting the same values for the second column. So my first entry will be 76, take away 86.1, which gives me minus 10.1. And then we're going to continue on all the way through the column. What I might suggest here is that you pause the video and try to fill in the second column on your own, and then you can double check your answers to make sure that you are getting the same ones. Okay. Now the third column, all we're going to do is take the second column and then square it. So all of these values should be positive. And they should be larger than what you have in that second column. So again, same thing, what you might want to do is pause the video, try these calculations on your own, and then check to make sure that you get the same answers. So this is great. We've got 2 columns of data here. We've got a lot of numbers. What we actually want to do, if you remember, is we're trying to calculate the standard deviation for this data set, okay, which is the square root of the sum of our deviations, the sum of the squares of the deviations, divided by our number of data points. So what we need to do to get our numerator is we are going to add this third column together to get the sum. So, and here we should get 804.9. This works out exactly to 1 decimal place, but for accuracy, you're going to keep this one to 2 decimal places if you had another number after that 9. Okay, so average, or the mean, is 1 decimal place. The sum of the squares of the deviations is 2 decimal places. Now we have all the information that we need to plug in here. So our sum of the squares of the deviations divided by our number of data points is going to give us our standard deviation, 8.97, which we're going to keep this one to 2 decimal places as well. So that means that on average, each data point, is about, the majority of the data is collected within 9 points of the mean. That's what that standard deviation means on either side. Okay, so let's take a look at one more example here, just to get used to the practice. We're going to go through the same thing. So first step is to write down your data points in your column here. 8, 2, and then 7. We've got the scores from a class on a data management quiz. The next thing that you need to do is to calculate the mean. Okay, so this is the sum of all your data points divided by your number of data points. So 59 divided by 9 data points is going to give us approximately 6.6. Remember, your mean, you're always going to round to 1 decimal place. To fill in the second column, we're going to take our x value and then subtract the mean that we calculated. So just like in example 1, what you can do is pause the video, fill in the column, and then start the video again to make sure that you are getting the same values. Again, we're taking our x value and taking away our mean. So you could get a negative or positive value, that is okay. For the third column, we're going to take the values for our second column and we're going to square it. So these should all be positive numbers. What you might want to do here is, again, pause the video, try to fill in the third column on your own using a calculator, and then double check to make sure that you're getting the same values. Okay, so our final step that we need to do is we're going to calculate our standard deviation. That was our whole goal in the first place. So our standard deviation is going to be the sum of the squares of our deviation divided by the number of our data points. Okay, and then the square root of that. So what we need to do is we need to add up our third column to get our sum here, which is 46.24. Remember that we're going to 2 decimal places when we find our sum of the squares of the deviations. And then we're going to put our values into our formula. So 46.24 divided by 9, which is our number of data points. And this is going to work out to about 2.27. So that means that the majority of the data is within about 2 points of our mean. We can also calculate the standard deviation of a data set using technology. You can use Google Sheets. You can use Excel. You can also use Desmos. And you can also use a graphing calculator. I guess I can put that in here. A graphing calculator to calculate it as well. This is a measure of how close the data is to the mean, which is important when you are making generalizations about survey results or experiment results.